Hi, this is Nathan, and for this next video I want to give another example of maximum likelihood estimation being used. So for this video, the example is going to be 10 Bernoulli random variables, each with probability of success, P. So for each one of those random variables, the PMF is equal to P to the xi times 1 minus P to the 1 minus xi. Now, this means the joint PMF is equal to the product from I equals 1 to 10 of P to the xi times 1 minus P to the 1 minus xi. We can just multiply them together because each sample is independent and they're all identically distributed. And now this joint PMF is equal to the likelihood function it's just P, there's no I there, or the log likelihood function is equal to the log of the likelihood function, so the log of I equals 1 to 10 P to the xi 1 minus P to the 1 minus xi. Or you can bring this log in from the video on logarithms if you don't remember that. So we have the sum from I equals 1 to 10 of the log of P to the xi times 1 minus P to the 1 minus xi. Or, distributing in this logarithm, we have sum from I equals 1 to 10 of log of P to the xi plus log of 1 minus P to the 1 minus xi, which gets us the sum from I equals 1 to 10 of xi log of P plus 1 minus xi times log of 1 minus P, right? And now I'm going to distribute in this summation. So we have sum from I equals 1 to 10 of xi times log of P plus sum from I equals 1 to 10 of 1 minus xi times log of 1 minus P. Right? Now we're going to take the derivative with respect to P, because P is the unknown parameter in this case, of this log likelihood function, and we'll get sum from I equals 1 to 10 xi over P plus sum from I equals 1 to 10 1 minus xi, it's a constant, over 1 minus P, but because the derivative of this is -1, this actually becomes negative, right? Now we're setting this equal to 0. So if you want to distribute in this summation, we have sum from I equals 1 to 10 of xi over P plus sum from I equals 1 to 10. We have a negative here, so that becomes positive. Xi minus 10 over 1 minus P. is equal to 0. So we have sum from I equals 1 to 10 xi over p plus sum of xi over 1 minus p minus 10 over 1 minus p is equal to 0. Or we have sum of I equals 1 to 10 xi over p plus sum I equals 1 to 10 xi over 1 minus p is equal to, just moving the minus 10 over to the other side, right? 10 over 1 minus p. This gets us, just going to multiply the denominators up to make this easier to solve. We have sum from I equals 1 to 10 xi times 1 minus p plus sum from I equals 1 to 10 xi times p is equal to 10p. Or sum from I equals 1 to 10 of xi, because we have xi minus p, and then xi times minus p, and then xi times p. So those will cancel out. So we're left with just the sum of xi's is equal to 10p. Divide both sides by 10, and we get p hat. Sometimes you write MLE in the subscript to signify we used maximum likelihood estimation to get this answer. It's equal to sum of xi's over 10. Now, if you go back to the last example, we had the sum of xi's, the sum of the 10 coin flips, was equal to 7, and we had that p hat, our estimate for p, was 0.7. And if you plug sum of xi's equal to 7 into this, we once again get p hat is equal to 0.7. So this is just another example highlighting that we get the same thing using either of the two methods, using 10 Bernoulli random variables or one binomial random variable to express the sample of flipping 10 coins.